Okay, so for your assignment for today, what you're going to be doing is you've looked at taking some notes about what potential energy was, and you know what kinetic energy is. Now it's time to put the two ideas together. So what you're going to be doing is your goal is to show, right, how potential and kinetic energy are involved with a moving object. Now, today is just a day for you to really try to get your ideas out there. Remember, you know that any object that's brought up in the air is going to have potential gravitational potential energy, right? If we let it go down a ramp or let it go, drop it out of the sky, gravity is going to pull that thing down. And as it pulls it down, what's going to happen is it's going to start to gain more of its speed. So today, where you're going to be submitting your assignment is to this assignment right here. So let's take a look. Just kind of jog your memory about some of the things we looked at a couple weeks ago. So one of them was this idea right here. So here you have the Galileo tracks. Let's take a look at the video again real quick. This is also, remember what I did in class for you all.
Let's give that a quick try. And we see it doesn't. How about if I try it from this side? And it won't do it from that side either. This piece was important because it was actually a piece that Galileo designed.
So remember, any object that's up in the air has gravitational potential energy. So here, when the ball is dropped over here, it has gravitational potential energy. As it starts to roll, that energy transfers to kinetic, right? Same thing over here. Over here, this thing has potential energy, gravitational potential energy, and as it rolls down the ramp, it transfers that energy to kinetic. So your goal today is to show that. And this is what we've done. So this is probably what you have in your notebook. It's probably something similar to this. It's not the exact same thing because, like I said, mine aren't always totally correct because I don't want to give you all the answers. But here, this model shows there's a track, there's a ball drop from the right side, goes to the left, ball drop over here from the left, goes to the right. But it doesn't show me anything about kinetic energy. It also doesn't show me anything about potential, right? You know the ball rolls, and as it rolls, it transfers more of that potential energy to kinetic. So I want you to find a way to show that. Okay, that way can be totally and completely up to you. So what you're going to do next is you're going to go ahead and on this page here, I want you to make a flip page. I want you to divide that flip page just right in half like this page already is. But this page is going to go above these models because we have more information now. So why don't you pause the video while you make your flip page. All right, now that you have made your flip page, your goal, like I said to start, is you want to add something to this model, right? How can you show how kinetic energy transfers to potential energy, right? How can you show how kinetic transfers to potential or potential transfers to kinetic? That is completely and totally up to you. And there's no right or wrong way to do it, right? I want you to show in your own way how the energy transfers, how you think it transfers, right? Do you know the final answer to this? No. And that's okay. But we will eventually look into this and learn about this. So I really want you to give it your best shot. Try to show in your own way how you think potential energy transfers to kinetic. And then we're going to go back and do the exact same thing for the short versus long track. But let's take a look at a video real quick to actually remember what that stuff was about. So here was another video. You have the long track down here, short track up top. And as we play the video, we can see that the ball on the long track finishes faster than the ball on the short track.
Now we're going to try another variation. In this case, we have, once again, the one track that is the shortest distance between 2 points. The track where the ball drops down now has a hump that it has to travel back up over and back down again before it finally reaches the finish point. Is this going to be enough to slow it down so that both balls are able to get over to the opposite side together? Well, let's see.
And like we just saw with the last one, we get the same results. Long track finishes slower than short track. So here, I want you to do the same thing, right? On your new model, there's kinetic energy and potential energy involved with both objects, right? There's kinetic energy and potential energy up here. There's also kinetic and potential energy involved here. And I want you to try your best. Try your best to actually show how you believe each one of those two things are involved. Okay? So right now, go ahead and make a new model. How can you show how kinetic and potential are both involved? How can you show one transferring to the other? Whatever method you choose is totally up to you, and it's correct. Whatever method you choose that you think, that's the one that's right. Because I want you to get used to you putting your ideas out there. If you don't put your ideas out there, you can't learn. So go ahead and pause the video while you work on your model. All right, so one last just piece of advice. Your models should not look like this. They will be much better than this. They will show kinetic and potential transferring between each other, right? Just to the best of your ability, whatever you think, okay? So don't submit to me a drawing that looks like this, okay? Because these drawings are all missing energy, right? There's nothing about energy in them, right? It doesn't show the why, the how, right? To give you a little bit of a hint, remember, the ball on the long track got to the end faster, so it probably has more kinetic energy. But listen, hopefully that hint helps. So really, I want you to make sure that before you submit this, it has everything you want to have about kinetic and potential. So where are you submitting this? Let's go check it out in Schoology. So here, this is where you will be submitting it. This is Galileo track and ramp models. So here you're going to draw just a picture. You're just taking a picture of that flip page you just taped in. One more time, this is the new flip page you just taped in on page. For me, it's page 23. For you, it might be page 25, but for me, page 23. So that you already have this page. You're just taping in a page on top of it. You are submitting me a picture of that, and that is due by the end of the hour. So if you have questions, make sure to reach out, send me a Schoology message. On that note, thanks for watching.